have you ever had your parents line you up on the wall and they put a little line above your head?
Yes. No.
And then when you get a little older, they do it again. Every birthday, they kind of measure you.
Yes.
They want to see how much you're going to do what? Grow. Okay? Now, I want you to look here. I have circles on the board. 1 circle, 2 circles, 3 circles. What do we think is going to go next?
4 circles.
4 circles. It's pretty obvious, right?
5 circles and 6 circles.
Well, you seem to know what you're doing, Natalie. Can you go and finish the pattern for me? Okay. What kind of pattern do you think this is? What kind of pattern do you think this is?
Triangle pattern.
A triangle pattern. Tell me, why would you say a triangle pattern?
Because, like, how the way you put the circles, it forms a triangle.
Okay. That's not quite what I'm looking for, but I like your creativity. I like your thinking. But what type of pattern is this? Yes.
I was going to say a stem and leaf plot.
A stem and leaf plot. That's something else we learned. You're using some mathlish, but that's not what we're looking for. But good answer. Yes.
A ones pattern.
A ones pattern. And why would we call it a ones pattern?
Because you add 1 to each number.
Great. That's a good observation. She says we're adding 1 to each one, but that's not the type of pattern it is. Remember we talked about a little child, and as they were
Growing. It's a growing.
a growing what?
Pattern.
Okay, it's a growing pattern. And why is it a growing pattern? I can't hear you unless I see your hand. I see your hand, Jules.
It increases by 1.
It increases by 1. So each number, it grows by 1. That's why they call it a growing pattern. Okay? Now, does everyone understand that?
Yes.
Yes. So if I were going to continue this to 20, how many circles would there be?
20.
It would be 20 circles, right? Because each step continues to grow. All right? Any questions on why I called this a growing pattern? No? Okay. Last class, we learned a very important math term.
Conjecture.
Conjecture.
All right, I got it.
You got it. 1 clap for Natalie. Good job. All right. Natalie, you said it. What is a conjecture?
A conjecture is like a hypothesis, but in math.
Okay, but what is that? If I had no idea what a hypothesis was,
It's like an educated guess.
it's like an educated guess?
It is an educated guess.
All right, but we're just using it in math, right?
Yes.
Okay. What I want you to look at, these are windows. This is 1 window, 2 windows, 3 windows, right? You see my windows? They may not look like the ones at your house. I don't have blinds and curtains, but these are my windows. And in order to make this window, I needed 4 sticks. We're going to consider each side a stick, okay? 1, 2, 3, 4. We understand that?
Yeah.
Yes. All right. So for this 1 window, how many sticks did I need?
1.
I only needed 1 stick to make this?
4.
Okay. How many people say I need 1? 1 stick to make this. Okay. Where's the 1 stick? Oh, talk to me. Why did you say 1?
I thought you meant by each side.
Each side. This is a stick. This is a stick. This is a stick. And this is a stick. So how many sticks do I need for 1 window?
4.
4 sticks. Okay. I need 4. All right. Now, for 2 windows, how many sticks do I need?
Either 6 or 7. I'm not really sure which one of them.
Okay, either 6 or 7. Think through it. I'm not going to let you get off that easy. You know I don't do that.
What I meant was...
Go.
Like,
Come on.
Like, I'm not sure, like, counting... Well, wait. Wait. Never mind. 5. Because this is 1 long stick, 3 short sticks, so 5.
Okay, he's not agreeing. Oh, I see a lot of answers, question marks on top of everyone's head. I see the question marks. Yes.
7 sticks.
Okay. Come show me and explain why.
You need 7 sticks because this is not a round stick. This is just like this one, but in 2. So you put 1 stick here, 1 stick here, 1 stick here, 1 stick here, 1 stick here.
Okay, use your blue marker. Get your blue marker and show me, just like I showed you here. This was 1. Show me where you have 7. Okay. Do we agree or disagree?
Agree.
We agree. All right. So for step 1, I'm just going to put step 1. We had 4. All right. So for step 2, how many?
7.
7 sticks. All right. Step 2, there were 7 sticks. All right. I need a volunteer to help me with step 3. Step 3. Kristen, you've been kind of quiet. Come on up. Step 3, Kristen. Okay, and what is your answer? Don't run away. Go back. Okay, tell us what your answer is.
The answer is
Count it for me. Count it out loud.
1, 2, 3, 4, 5, 6, 7, 8, 9,
10. Do we agree?
10. Yes.
All right, so for step 3, how many sticks?
10.
You don't seem sure to me.
10.
Oh, okay, so we do agree that there are 10.
Oh. It's like this, and then you start out with 4, and then you have 3 more, and then 7, and then 10. Thank you.
Exactly what we're doing. And what is that? What is that?
Kind of a pattern, you have to find it sometimes.
We find the in and out. Keep talking to me, but there's a term that we call these. There's a term that we call it. Who remembers? If you remember input and output, you should remember, yes. Come on. Out and in and out. Yes. Increase and decrease. Oh, God, you're using some great words. But what is this table just called that he just made? Starts with?
Andre, please come to the main office. Andre, please come to the main office.
Starts with an F.
No.
I think I heard someone getting ready to say it. Next letter is a vowel.
What's the next letter?
You want me to just spell it out? You want me to just give it to you?
No.
Well, think. Come on. Put those thinking caps. I heard it. Table 1. Thank you.
Teaching the vocabulary of mathematics does not need to be a standalone portion of the lesson. For example, terms such as equivalent, sum, functions, integer, etc. need to be explained in order for students to understand the problem they are to solve. Additional vocabulary should be taught within the context of the lesson so that students are developing the mathematical understanding that is linked to that particular vocabulary word and not simply learning a definition.